Good morning, students. Today we'll be discussing differences between metals and non-metals and physical and chemical changes. So we have studied that matter are of two types based on their chemical properties, pure and impure. Elements are pure matters. Around 118 elements exist in nature. Out of those, around 94 are natural and rest are man-made elements. Among them, 2 elements are liquid in state like bromine and mercury, whereas 11 of them exhibit gaseous state like hydrogen, oxygen, nitrogen, etc. Thus, most of them are solid in nature. Cesium and gallium, these are solid at room temperature but tends to change into liquid when temperature increases. That means they have very low melting point. Now this is a table which shows the comparison of the properties of metals and non-metals. This is basically the differences in the physical properties. So here the properties are shown: luster, hardness, malleability, ductility, conductivity, physical state and density. We'll discuss one by one. Let's begin with the luster. Luster, all of you know, that means metallic shine. All metals, they have a luster, whereas non-metals, they don't have any luster except for iodine and graphite. Second is hardness. Metals, they are very hard. Again, we have two exceptions here: sodium and potassium. They are so soft that they can be easily cut even with a knife. Non-metals, they are not hard, but there is one exception here: diamond. Yes, of course, it is the hardest substance known. And next, third is malleability. You know that malleability, it is the property due to which a substance can be beaten into thin sheets. Metals, they are highly malleable except zinc, antimony and arsenic, whereas non-metals, they are non-malleable. Next, fourth is ductility. You know that ductility, it is the property by which a substance can be drawn into wires. Like metals, they are ductile. Again, we have the same exceptions here: zinc, arsenic and antimony. Whereas non-metals, they are non-ductile except carbon fibers. Next, fifth is conductivity. All of you know that metals, they are good conductors of heat and electricity. Now we have two exceptions here: bismuth and tungsten. And next, non-metals, they are poor conductors or bad conductors of heat and electricity except for graphite, which is a type of carbon only, and gas carbon. And next point is physical state. Metals, they exist in solid state at room temperature except mercury and gallium, which are found in liquid state. And non-metals, they may be found in all the three states like solid, liquid or gas. Now density, when we compare, metals, they have high density except for sodium and potassium, they have comparatively lower density. And non-metals, they have low density except for diamond. Now students, there are some elements which show or which exhibit the properties of both metals and non-metal. Such elements are called metalloids, like germanium, silicon, boron, arsenic, tellurium. These are some of the examples of metalloids. Metalloids are usually too brittle. Brittle means they are very soft to have any structural uses, and their compounds are used in alloys and semiconductors. Now we'll discuss the differences between the physical and chemical changes. Physical change, those changes in which only physical properties of the substance change but no new substances are formed, are called physical changes. For example, like melting of ice to form water and breaking of glass, preparing a solution, etc. These are examples. And chemical change, those changes in which new substances are formed, are called chemical changes, and chemical properties of a substance get changed in a chemical change. For example, rusting of iron, burning of piece of paper, etc. These are examples of chemical changes. We'll discuss one by one. Let's begin with the physical change. A physical change brings about change in physical properties such as physical state, that may be solid, liquid, gases, and shape, size. So only the physical properties get changed. And second, there is no change in chemical composition of a substance during physical change. That means since no new substance is formed here, so we can take one example here, like suppose if you melt ice. If we see the chemical formula of ice is basically, since it is water, so we'll write H2O, and when you provide heat to it, it get converted into liquid water. That also has the same chemical composition and the formula H2O. So since no new substance is formed here, it's an example of a physical change. And third, of course, no new substance is formed here, that we have already discussed, and it's a temporary change and hence reversible. That means suppose if you are melting ice into or converting it into liquid water, that you are capable of doing because you are providing heat to it. But once you reverse the condition, that means if instead of heating, if you start cooling water, you'll again get ice. So that means these type of changes are examples of physical changes. You can take one more example, like tearing of paper. Suppose if you tear a paper, you can only turn it into smaller bits of paper or small pieces, but no new substance is formed here, and paper, since it is made up of cellulose, it will remain the same. And a chemical change brings about change in chemical properties. Yes, of course, here the chemical properties get changed, and there is a change in chemical composition of a substance during a chemical change, and a new substance is always formed. So we can take one example here. Again, let's say the same paper we are taking. Initially, when you tear that paper into smaller bits, you could get only the smaller pieces. That's it, and no new substance was formed. But when you start burning that paper, so that will turn into ash, that is carbon. So it means paper is basically made up of cellulose, and which has three elements: carbon, hydrogen and oxygen. But when you provide heat to it or when you burn it, it get converted into ash. That means only carbon is left. So a new substance is formed here. So that's an example of a chemical change, and it's a permanent change and hence irreversible. That means once you burn that paper and turn it into ash, you cannot get back the initial paper just by reversing the condition. So here chemical changes are irreversible. But in higher classes we'll discuss there are certain chemical changes which are irreversible also, which are reversible also. That means which can be in which initial substances can be obtained back. But here please do remember that it's not so for all the chemical reactions. So chemical changes, they are generally irreversible. That means once the new product is formed, we cannot get the initial substances back. So these are some of the examples of physical and chemical changes which you see in daily life: melting of ice, physical change; chopping of wood; shredding paper; and mixing gray and green marbles. So here you won't get anything which is new, right? So that means these type of changes are physical changes. Whereas here, if we compare with that of the physical change, and these are chemical changes, like burning of wood. When you burn wood, it gets converted into ash, a new substance is formed. Mixing vinegar and baking soda, a chemical reaction takes place and carbon dioxide is released. As you can see here, froth is forming, means new substance is being formed here. So that means it's an example of a chemical change. Fireworks, yes, chemical reactions takes place there when you are providing heat to it. Rotting banana, yes, again this is also an example of a chemical change. So I hope you have understood the differences between the physical and chemical changes. So with this, we come to the end of today's topic. Thank you. Thanks a lot.